Today we will see how to map mate pair reads generated by SOLiD instrument. But before we go to Galaxy, let me explain a little bit about mate pairs in SOLiD and a little bit about data formats. Important thing to remember is that mate pairs generated by SOLiD instrument are going the same way. This is quite different from Illumina, where they are looking at each other. So once again, in SOLiD, mates go the same direction. They're essentially on the same strand. So when you do sequencing, when you get mate paired reads from SOLiD instrument, you essentially get two sets of files. The first set of files is for the first mate, and these are typically indicated by F3 right here. And you get reads and you get qualities. And the second set looks very much the same, but these are the second mates or R3 reads, as you can see here. So both of these, forward and reverse, are color space reads and qualities in this format. The mappers that Galaxy utilizes, Bowtie in this case, require you to convert these data sets into FASTQ format, which for forward mates or for the first mate will look like this, where the mate is indicated by /1, and for the second mate by /2. And I will explain to you how to do all of that. Here I am in Galaxy, and I have 4 data sets in my history. I have color space reads and quality values for my first mate, or F3 files, and I have the same set for my second mate, or R3 files. So in total, I have 4 data sets. First thing I will do is I will go to NGS, QC, and Manipulation, scroll down, and select Convert SOLiD Output to FASTQ. And at this point, I need to go and check this, switch this to yes. And the question here, is this a mate pair run? And it is. And once I do that, I will be able to select my forward reads and reverse reads. So for forward reads, I will select 1 as the reads and 2 as the qualities, because these are my reads and these are my qualities. And for reverse, I will select 3 as my reads and 4 as my qualities. This tool allows you to filter reads based on a certain quality threshold, meaning that if you set anything here above 0, this tool will not report any reads which will have color calls below that quality. How do you know how good your reads are? Well, for that you should see previous screencast where I explain how to get an idea how good the quality distribution of the color calls is. But here what we're going to do is we're just going to select our forward reads, reverse reads. We're not going to touch anything here, and we will keep these settings as they are for the Bowtie, because that's the mapper we will be using, and we'll click Execute. This tool generates 2 outputs. The first output will be FASTQ for forward reads, and the second will be FASTQ for reverse reads. Let's just wait a few minutes for this to finish. Now it's done. And if you expand this, you will see that these are FASTQ for forward, this is FASTQ for reverse. And now I will go to NGS mapping, select, scroll down, we'll choose map for with Bowtie for SOLiD. And here I will choose, instead of single end, I will choose paired end. And once I do this, it will allow me to select the distance between mates, and that depends on your library preparation parameters, and in this case it's actually 1 KB. So what I will need to do is I will need to enter the FASTQ file for forward reads, FASTQ file for reverse reads, that's my dataset 5 and dataset 6, forward reads, reverse reads, forward reads, reverse reads, and orientation, which here is FF by default for SOLiD, and I will click Execute. Now mapping is done. Bowtie produced output in the SEM format, and I can actually rename this history. I will call this